Good morning. Let's look at modular arithmetics. Okay, question 1. An operation is defined on a set X. The set is X, 1, 3, 5, and 6. The set of numbers has been given to you by M operation N. So this is a formula. M operation N is equal to M plus N plus 2, mode 7, where M and N are all members of the set given to you. We are going to draw a multiplication table for the operation. So we are going to draw a multiplication table for the operation. So the set of numbers 1, 3, 5, and 6. So we have 1, 3, 5, and 6. So also have it vertically, so which is 1, 2, 1, 3, sorry, 5, and 6. So this is the operation. So this is the operation. So this is it. This is the table. So the formula given to us in the question is M operation N is equal to M plus N plus 2. Then we have mode 7. We are going to use this formula to fill the table. We are going to use this formula to fill the table. So we are going to start with 1 operation 1, 1 operation 3, 1 operation 5, 1 operation 6. Then we'll come again, 3 operation 1, 3 operation 3, 3 operation 5, 3 operation 6, 5 operation 1, in that order. Okay, so here 1 operation 1, we are going to have 1 here, operation 1 operation 1, 1 operation 1 is equal to, we are going to have 1 plus 1 plus 2. That's the formula, M plus N plus 2. So our M here is 1, our N here is 1. So 1 plus 1 plus the 2 already in the question. Then whatever we are going to get, the result mode 7. So 1 plus 1 is 2, plus 2 is 4. So 4 mode 7. So 4 mode 7 is the same thing as 4. Then we'll pick 1 operation 3. So we're going to have 1 operation 3, which is equal to, now in place of M we have 1, in place of N we have 3. So we are going to have 1 plus 3 plus 2. That is the formula, mode 7. Okay, mode 7. So we are going to have 1 plus 3, which is 4. 1 plus 3 is 4, plus 2, 6. So we're going to have 6 mode 7. 6 mode 7 is 6. The result you are going to get, if you are confused, the result you are going to get, if you get the result which is less than the what? The mode, then you pick the result. You don't have to do anything. But when the result is equal to or greater than the modular, then you pick the remainder. I take that again. Whatever answer you are going to get, for example, 1 operation 1, after using the formula I had 4 mode 7. 4 is less than the modular, so what do I pick? I picked 4. Then when I came to this one, I had 6. 6 mode 7. 6 is what? Less than 7. Then I picked 6. Let's get to the last, the third one, which is 1 operation 5, which is equal to 1. In place of M, we have 1. In place of N, we have 5. Then plus 2, mode 7. So 1 plus 5 is 6, plus 2 is 8. So I'm going to have 8 mode 7. 8 mode 7 means how many times? This is the result I got. This is the result I got, which is 8. So 8 is greater than 7. The 7 is the modular. So what do I do? It means that how many times will 7 enter what? 8. 7 can enter 8 only one time. Only once. Remainder what? 1. So I'm going to pick the remainder. So remainder 1. If it is a number basis, I'm going to pick the number of times the 7 will enter the 8 and the remainder all. So I'm going to say 1, 1. But this is not number basis. This is what? Modular arithmetic. So don't be confused. So here we pick only the remainder. In modular arithmetic, we pick only the remainder. So how many times will the modular enter the result you got? So one time. One time that 7 will enter 8, or 7 can enter 8 only once. leaving a remainder of 1, and that is the one we are going to pick as our answer. Let's get to 1 operation 6. 1 operation 6 is equal to 1, which is in place of m, plus the n is now what? 6 plus 2 mod 7. That is the formula. It's in the question. M plus n plus 2. M plus n plus 2 mod 7. So 1 plus 6 is 7 plus 2 is 9. So 9 mod 7. 9 is greater than the modular, which is 7. 9 is greater than the modular, which is 7. What do I do? How many times will 7 enter what? 9. Only once. Leaving a remainder of what? Leaving a remainder of what? 2. So the answer is what? 2. The answer is what? 2. So that is how you fill the table. That's how you fill the table. So this is the table. This is the table. So we fill this together. Then this 1 to 3 operation 1 means 3 plus 1, which is 4, plus 2, which is what? 6. So 6 is less than the modular, which is 7. So you pick 6. So you do that and fill the table all. The last one that you have 0 here is 6 operation 6, which means 6 plus 6, which is what? 12 plus 2, which is what? 14. So 14 modular what? 7. How many times will 7 enter what? 14. 2 times, leaving no remainder. So that's what we have in 0 here. So this is the table. Okay, so you are done with the I. Let's come to II. I'm going to divide my distance. We are going to have II. Using the table, we have our table here. Using the table, this is the table. Using the table, find the true set of 3 operation n is equal to 3. So we are coming to this table. We are coming to this table. This side of the table. The answers you got. This side of the table. To pick 3 operation, what number will give you a result of 3? So 3 operation what will give you 3? So 3 operation 5 will give you 3. So 3, that is I, alpha. So we are going to have 3 operation 5 is equal to what? 3. 3 operation 5 is equal to 3. So because they say using the table, find the true set, it means that this is n. So we are going to have n, decide that n is equal to 5. This is our answer. 5 is our answer. N decide that n is equal to 5. Let's get beta. Beta. N operation n is equal to 3, which means the number you are going to put here should be the same thing as the number you are going to put here. So when you come here, we pick 1. 1 operation, so it should be operation 1, and the answer should be 3. So 1 operation 1 will not give you 3. When we come here 3, it means 3 operation 3 should give you what? 3, but we didn't have 3. When we come to 5, it means 5 operation 5 should give you 3, but 5 operation 5 didn't give us 3. 6 operation 6 will give us 3, but 6 operation 6 didn't give us 3. So this is n and n, so the same number. So 1 operation 1 did not give us 3, 3 operation 3 did not give us 3, 5 operation 5 did not give us 3, 6 operation